Okay, so polynomial function. A function, that's shorthand for function. A function that contains only the operations of multiplication and addition with coefficients, exponents, and two variables. So another way to think of this is also it's polynomial functions only have whole number exponents. So you're not going to have, it says multiplication and addition, so there's no division. You can't have like 2 divided by x. You can't have square roots. So usually our functions look pretty basic. There's 2 examples given here. F of x, which stands for y, equals 5x squared minus 3x plus 7. That's a polynomial function, right? We have whole number exponents. There's only addition and multiplication going on. Or 3x plus 9. So we're specifically going to focus on, there's linear functions. We have quadratic functions. We're going to look at cubic functions. What does a quartic function look like? Okay. So a bunch of it is review. You've looked at linear functions when? Grade 10, right? Quadratic functions, grade 11. So we're going to extend our knowledge with cubics and quartics and all that fun stuff. Okay. Got it down? Good to go? Okay. So quick review, what's a relation versus a function? Do you guys remember this? Kind of new. A relation versus a function. It's not in your notes. Just want to discuss it really quickly. Okay. This is grade 10. So relation, what the root of relation is relate. Right? To relate. So relation is just comparing two things, finding a relationship between two things. So relationship between two things. Now function had to pass the vertical line test. For each x, there is only one y, right? Each x has only one y. Each value in the domain has only one value in the range. So do you remember the vertical line test? Okay, the vertical line test, the VLT, it should only ever cross the graph once. So a circle, for example, is a relation, but not a function. Because if you draw a vertical line, it goes through more than once. Okay, so we're studying functions, polynomial functions. Right? Moving on. Okay, let's look at the function y equals, let's delete this. Grab your graphing calculators. Okay, and we're going to graph y equals 5. Graphing calculator. There's, remember Love Works? They came and spoke at our school. Open. Okay, lost my train of thought. Okay, so let's graph this. Ooh, that's pretty. Y equals 5. So just y equals 5 and push graph. Your windows should be normal. How do we reset our windows? Zoom 6. Zoom 6. It's the easiest way. And there you go. So that's what your graph should look. It's a horizontal line at 5, going through 5. Okay, something like that. No. Okay, recall. What is degree? How do we spot degree? Like, what's the degree of this function? Does anyone know? No, that's domain. Close. Z word. So degree is the highest power on the variable. Highest power on the variable. Is there a variable on x? On the variable x. Is there an x here in this equation, y equals 5? No. And so this has a degree of 0. Okay? So it's what we call a constant function. Okay, whenever you have just y equals a number, that's just a constant function. Okay, how many zeros? Does anyone remember what a 0 is? It's an x-intercept. So we can call our x-intercepts, we call them zeros, and sometimes we also call them roots. Right? These are all the same thing. Roots, zeros, and x-intercepts are the same thing. Okay, do we have any x-intercepts here? No, it doesn't cross the x-axis, so none. 0 or none. 0 zeros. Yeah. Identify the number of y-intercepts. 1. Where is it? What's the y-intercept? Y equals 5. Or you can write it as 0, 5, or y equals 5. Okay, before you turn the page, we need to learn how to each quadrant has its own number. Okay? Does anyone remember what this quadrant is? 1. Okay? So this is quadrant 1, and we use Roman numerals. So we start where the y is positive and the x is positive. Now, do we move clockwise or counterclockwise? Counterclockwise. So this guy is 2. This is quadrant 3. And then last is quadrant 4. Okay, you have to know the quadrant numbers. Okay, so it says describe the end behavior. Describe the end behavior. Now graphs, we always move left to right. Okay, left to right. So this graph, moving from left to right, starts at quadrant 2 and then goes to quadrant 1. So when it asks to describe the end behavior, we say line extends from quadrant 2 to quadrant 1. So it goes from quadrant 2 to quadrant 1. Domain of our graph. So domain, we ask how far left and right does this graph go? Forever. So we say that x is an element of the real numbers. Range, how far up and how far down does this graph go? Y equals 5. It's only ever at 5. So turning points are points where you can think of them as bumps in the curve where you're going from an increase to a decrease or a decrease to an increase. Do we have any turning points on this graph? No, so we have none. 0. Number of turning points is 0. Okay. Linear functions. Remember they have the equation mx plus b. It's always usually in the form mx plus b. What does m stand for? Slope. Good memory. B is the y-intercept. Okay. For given 2 points, we need to find slope. We use y2 minus y1 over x2 minus x1. Do you remember that? Sort of? That's like a long time ago. Okay? And one other equation you need to know for lines is when you're given a point and the slope. So you know your slope and a point. We use the slope point formula. Y minus y1 equals m times x minus x1. So this was a long time ago. Was it? Oh, nice. We looked at a little bit of it. For sure, quadratic was a little different. But we did use slope formula for sure. Yeah. Okay, so what's the degree of this function? Dean. Degree. What's the degree of the function here? The highest power of x. What's the exponent on x? The exponent on x. The power. It's 1. So the degree is 1. Stop playing with your energy drink. Okay, so degree of a function, we look at our x, our exponents on x, what's the highest power we see for the x. So if you had y equals 4x cubed plus 3x squared plus 5, what's the degree on this function? Degree would be 3. So the highest power is 3. That's degree. Okay, degree 1 functions are always linear. So if it's degree 1, it's always a linear function. It's a line. Degree 0 is always constant. Degree 1 is always linear. What's wrong? This? Linear? Okay. My A's sometimes be turned into those. I'm trying to do this. I don't know. It's not real A. No, it's the function. It's like, look. It's the computer A. What's a real A? Okay. Okay, sketch it. So let's plug this in our calculators. I'm a human being. Y equals, this is very exciting, 3x minus 1. Okay, so where does the graph start? Where's the y-intercept? Sorry. What's the y-intercept here? -1. So this is the y-intercept. So y-intercept is at -1. That's the first point we're going to plot. Okay. What's our slope of this graph? 3. It's the number in front of x. That's our slope. So we usually want to change it to a fraction. How do I change 3 to a fraction? 3 over 1. It's always rise over 1. Run. Thank you. So we're going to go 3, what direction? Up, 1, right. Because they're positives. +3, +1. Up 3, right 1. Up 3, right 1. Yeah. If we want to go the opposite direction, we have to switch both their signs. So down 3, left 1. Down 3, left 1. Fun times, right? Those were the good old days. Yeah. Okay. So linear functions, yeah, the slope is the coefficient, the constant is your y-intercept. Okay, so where's quadrant 1 again? 1, 2, 3, 4. There's no 5. No, there's no 5. Okay, so how many zeros does this graph have? 1. It's the x-intercepts, right? How many x-intercepts? It has 1 x-intercept. How many y-intercepts? 1, and it's at y equals -1. Shh, girls. Seating plan this close. Everyone else will be mad at you. See, Dean? Okay. Describe end behavior. What's the end behavior of this graph? Always move left to right. So where are we on the left? 3, 2, 1. What you want to say where it extends. So begins and ends. Okay, so it begins at 3, ends at 1. Extends from quadrant 3 to quadrant 1. Good old Roman numerals. They're not dead. Okay, what's the domain of our function? Domain. How far left? Forever. How far right? Forever. So XER. What's our range? How far up and down? YER. Forever. Are there any turning points on this line? Whoops. No. A turning point is when you're going from like a decrease to an increase. So there will be like a curve. I'll tell you something about the turning points. It's always one less, usually one less than the degree. So this has a degree of 1, so it has 0 turning points. A degree of 2 would have 1 turning point. A degree of 3 would have 2 turning points. Cool. Okay, maybe not. So, none. Yeah, it is. Okay, we're almost done. Not really. Nice. It's because we had a long quiz and then a speech. Quadratic functions. What do quadratic functions look like? Okay. What's a quadratic function look like? A curve. A smiley face or a sad face? Okay. Quadratic functions always have a degree of 2. Degree of 2. Graph it on your graphing calculator. Just did. So y equals x squared. You have 2 options. You can use the hat or little x squared button there. There we go. So it's starting at 4. Looks like that. Oops. Something. Okay. Got it drawn? Seen? Drawn? Drawn? Is it drawn? That's at 4, yeah. It's touching 4, sorry. I said drawn. Maybe. We're going to fight. Okay, got it, Dean? Yep. Okay. Number of zeros. How many zeros do we have? X-intercepts? None. Right, doesn't cross the x-axis. Identify the y-intercepts. 4. It's at 4. We have one of them at 4. Y equals 4. And behavior. Where is it starting? 2 to 1. Yeah, 2 to 1. So extends from quadrant 2 to quadrant 1. Domain. Domain of this graph. So how far left and right? Does it keep going to the left and to the right? Yeah, so we'd say XER. Range is how far up and down. Where does it start? 4. So we'd say Y is greater than or equal to 4. If it was opening down, we'd say less than or equal to 4. Number of turning points. So if our graph looks like this, how many turning points? Here it is. We have 1. Woohoo! Okay, last. Cubic function. Finally, we can see something new. So cubic functions, we're just going to draw them to the side here. So cubic functions, where did I draw? Okay, here. So they can look like this, or they can be a little bit more smooth, like that. Okay, so it's like if you took a quadratic, one side opening down, one side opening up, kind of put that part together and that part together. They can also start quadrant 3 and end up in 4. 2 end up in 4. Or look something like this. Okay, that's a cubic function. Cubic functions will always have degree of 3 cubes, right? 3 dimensions. So it's degree 3. We're going to graph 5x cubed. 5x cubed. So grab your calculators. 5x. Now how do we do power of 3? You could either go math 3 or you can go hat. 5x the power of 3. Enter. Okay, so this looks like this. Okay, so our graph goes through 0, 0. You can kind of plug in some points. If we plugged in x is 1, what's 5 times 1 cubed? 5 times 1 cubed. What's 1 cubed? So we can get points. 1. 1 times 5? 5. So here we go. It's right there. That's our point. And on the other side, if we had 5 times negative 1 cubed, it would equal negative 5. So negative 1, negative 5. So those are the points. So this is like really tough because we should have given you a different scale maybe. Oh, that's ugly. Yeah, it's hard to draw on these big things. Give me some credit. Where's the creds? Sorry. Yeah. Okay. Does everyone have that drawn? I didn't say John. I said drawn. Okay, number of zeros. 1, and it's at 0, 0. X equals 0. Y-intercepts. Cross the y-axis. How many times? Once. It'll always be once. The end behavior. Where is it starting? 3, 1, 2, 3. 3, 2, 1. So extends from quadrant 3 to quadrant 1. Domain, XER, range, YER. All odd functions will be XER and YER. It's a cubic, which is an odd function. Number of turning points. Okay, it's really hard to see. So it's easier to see when it's like this. You can see your turning points very easily. Even if it's like this, it still has 2 turning points. Because it's increasing, and then it decreases for a bit, and then it increases. So 2 turning points. We also know it's 2 because it's degree 3. It's always 1 less than our degree. All right. So homework for today, if you grab your workbooks, and it's kind of 2 parts. Turn to page 114. Okay? Turn to page 114. So your homework I'm omitting a couple questions, okay? So number 1, 2 ABC, so you can omit, omit D. So on page 114, omit D. 3 is good. 4, A, and C. No, I meant D was, sorry. And then 5. Okay, so you're omitting 2D, 4BD. Okay, and then also there's one question you have to do for page 117. So just the number 1, ABC. So there's only one question. Okay, so the homework solutions are already on the website. The practice exam solutions are already on the website. There's a couple corrections to them. So I'll tell you those. Stacy, take that. It's the second time today. Addicted. Okay, we are all addicted, not just you. I am too. I know. I'm saying we. We. I deleted my Facebook this weekend just because I was like, I'm done with it. And then, like, not even 24 hours later, I was back on. Not that I never post anything. Just gonna get rid of it. I have Twitter, but anyways, so I like to look at my weather on the Google weather. That's why. I know, I am 80. The solutions for the practice exam, the solutions for that chapter test, and then these notes and this homework is already up on the website. Okay? So tomorrow, you're working on the practice exam. Actually, can I just tell you the corrections now? Can everyone bring out the practice exam? Because I won't be here tomorrow afternoon. Okay. Yeah? Yeah, I'll do that. I'll do that. Okay. It's just like a numerical response. 2 numerical response, 1 multiple choice error. But the solutions are online, and then our exam is Friday, right? So you might want to work on homework from this right now, or you can start working on probability stuff.